Okay, so this topic relates to productivity. We can say here that plants can be grown to be used as fossil fuels. So they grow, so they use light energy, convert it to chemical energy in the biological molecules within the plant, in photosynthesis, and then that plant biomass can be the plant can be dried out, and you've got the dry biomass, and you can burn it to release energy. So that's how plants can be used as a fuel. So the question is which type of plant is best. When looking at this, you also need to allow comparison between results to decide which plant is best. So that's why we've got the units here. So first of all, we've got the dry mass, and that allows comparison because the water content of different plants would vary, and the water, you can't sort of gain energy from burning water. So it allows comparison to make sure that you're just looking at the dry biomass, you're not including any water, because the water content could vary per plant, and water has mass. Also, we're looking at per hectare. So per hectare allows comparison because it could be a different sized field. So if you just looked at the total energy output, if one field was bigger and had more plants in it, then that would probably produce more energy when you burnt them. So per hectare then allows comparison. One of your questions says elephant grass is the best, and to evaluate this statement. So what points have we got? So first of all, probably the most important point is there is the highest yield. So you get the highest yield of elephant grass per hectare. So it's quite a lot more, up to 25, which is double more than double either of these. It's the highest yield. Remember, it's a comparison. So it's the highest yield. And what does this mean? It means that less land is needed to grow that crop. So you're actually using less land as well, which might make it cheaper. Another thing is as well to factor in, so you have to bear in mind costs. Is it takes the least time to dry out, so it's quicker to dry. It's going to take the least time to dry out because there's the least water content in it. So if it's quicker to dry out, that means you can use it as a fuel faster. You've got less costs involved with drying out the product. So that's another good point, agreeing with that idea that elephant grass is best. Another thing that agrees with this point is it's the longest living. So you don't need to replant it year after year. For these two, you'd have to replant, which costs money every single year. Whereas for the elephant grass, you've got 20 years out of it. It keeps regrowing every year, so you don't have to replant it, which costs money. Also, you don't need to buy seeds every year because you can grow new plants from chopped pieces of root. So you just break off a bit of root, replant it, and you don't have to buy new plants, new seeds every year if you want to grow more of them. So that's another positive point, that's going to be cheaper. But there are some disagree points, and the disagree points are more to do with the environment. So first of all, this species is from Asia, so it could be a possible alien species, so it could come along, it could interfere with the food chains, the food webs, and there's a question later on about. So the last question links in with that, why could that be an issue? So we'll just go through the answer to that one now. So if you've got an alien species coming in, that's going to there's going to be loss of habitat for a native species, so it's going to take up land where the native species could grow, which means you've got less diversity of plants and food sources, so because you've got this monocrop rather than a range of different plants which would be growing instead of it. It's going to lower the diversity of insects as a result, because you're going to have less things which can feed off the plant or act as habitats. So there's going to be less habitats and food sources and niches for insects. There's going to be less diversity of insects, which means that you're going to lose some food chains, some food webs are going to be disrupted, so overall the community is going to become less stable. So going back to the evaluate question, we've had a lot of agree points, so highest yield, so you need less land, lowest moisture content, so it takes less time to dry out, it lasts the longest, so you don't need to replant it as often, and you can grow it from root pieces, so you don't need to buy seeds every year. We've had the negative that's from Asia, so it's an alien species, so it could become invasive and make the community less stable. There is one more negative point, and that comes in with the next. And this shows that there is significantly less native species over time. So this goes in with the idea of the alien species elephant grass coming in and lowering the biodiversity of the area. So you can see that over time, the first 3 years, it didn't seem to have much an effect because the standard deviations overlap, and if anything, perhaps it increases the biodiversity. But then after 4 years, the number of native species per quadrat has completely dropped to 0. So much lower biodiversity, so negative point. So resource C, dry mass. You need to understand how the dry mass can be worked out and why it's important. That's what this is about. So this is what they would do. So over time, They measure the mass of the plant, so it's heavy at the start because it contains a lot of water. Over time they measure the mass at various intervals, and until the mass then remains constant, all the water won't have evaporated out from applying heat. You know you've got the dry biomass when you've got constant mass, which shows that no more water is being lost. You can work out the difference. That would then indicate the mass of water that's been lost by the plant. So if I have a dry biomass, this now allows comparison because each plant would have different water contents, and water has mass. And the water doesn't include the energy in the organic molecules that the plant has made. So this is looking at some other plants that could be used as a biofuel. So we're looking at rape and we're looking at soya. So two different plants, so rapeseed oil and soya plants compared to sort of oil, which can be used as well as a fuel. So looking at this, just when you look at the numbers, it looks like this might be the best for the environment. But a lot of these things are it's just subjective, high, medium, low. It's not quantitative. You can't really compare any of these. So that's not very useful. A bad point for soy would be that it has a very high impact on the land needed. So that's land where you'd have to perhaps the native environment wouldn't be there, so it's going to be taken over by soya plants. So that it could cause local extinction of species. It could disrupt food chains and food webs, reduce habitats and niches. So planting soya could have a big impact on the environment. So although we only have sort of a subjective, non-quantitative amount of fertiliser needed, if you were to have a statistical test which you could show how much fertiliser do you need compared to the yield of biofuel crops, so question 4, you'd have to use this sort of statistical test. So you'd have to do a correlation coefficient. So if you're going to plot fertiliser used against yield of biofuel crop, would you see a correlation, or would it be a significant correlation? So a correlation coefficient would be a bit like so Spearman's rank or Pearson's rank. So to do that, what you'd have to do is you have to rank the data for each variable from lowest to highest. So you could give the lowest concentrations of fertiliser a score of 1, 2, 3, 4, 5, etc. and then pair that up with the yield of biofuel crops and give each one a rank. So rank the data for each variable from lowest to the highest. You then have to compare, so calculate your Spearman's rank and compare the R value against the critical value at P is equal to 0.05. And if your value is larger than the critical value, then you've got a significant correlation. What sort of correlation depends on this. So if you've got an R value of 1, it means you've got perfect positive correlation. A value of 0 means there's no correlation whatsoever. And an R value of -1 would mean you've got perfect negative correlation. So if your R value was greater than the critical value at P equals 0.05, then you could say that you've got significant correlation, and the likelihood of this correlation being due to chance is less than 5%.